Good morning. This is your Stat Sensei, Mr. Spensei, and this is geometric distribution, and this is terminals. All right. It says seatbelts, but it's terminals. So the probability that any terminal is not ready to transmit is 0.95. So it looks like we have a probability of 0.95. How many terminals would we expect to test to find one that is ready to transmit? Basically, this is a weird way of saying it, but how many are we going to test until we find the first one that's ready to transmit? So find one or find the first one that is ready to transmit. The fact that it's indicating first, even though it doesn't expressly say it, lets me know I'm working with a geometric. Well, ready to transmit is 0.95, and I know the expected value formula for the geometric is 1 over p. So in this case, 1 over 0.95. And if I take 1 and I divide it by 0.95, I end up getting 1.0526. So equals 1.0526. I would expect to have to test 1.0526 to find one that's ready to transmit. All right, next one. How many terminals will we need to test to find one that is not ready to transmit? Hold on just a second. Ready to transmit is 0.95, so not ready is 1 minus 0.95 equals 0.05. So our probability for this problem is 0.05. Okay, so we have a probability. Well, I need to say that this is a geometric, and I know it's a geometric because I'm looking to find one. I'm looking to find the first one. So this is a geometric. And let x equal the number of terminals to be tested until we find the first that is not ready. Really, I could write not ready to be transmit, but I'm kind of out of space. All right. So how many will until we find one not ready to transmit? Well, that's going to be again the expected value. This is asking for how many will we have to test. So expected value in this case is 1 over p, which in this case is 1 over 0.5. So if I go 1 divided by 0.05, I end up with 20. We expect to have to test 20 terminals. What is the standard deviation of terminals that are not ready to transmit? Well, the standard deviation formula is the square root of 1 minus p over p. This is the standard deviation for a geometric. So in this case, this is not ready to transmit, and we know that p is 0.05. It's going to be 1 minus 0.05 under the radical divided by 0.05. So let's do the first part first. 1 minus 0.05. Oops. 1 minus 0.05. And I'll press enter. Then I'm going to raise that to the half power. That just took the square root of it. And I'm going to divide by 0.05. Divided by 0.05. And we end up getting 19.49. So our standard deviation is 19.4935. What's the probability the first terminal not ready to transmit is the 10th terminal tested? All right, so 1, 2, 3, dot, 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 9, 10. I have a singular value. If I'm circling a singular value, then I can use the geometric PDF. Once again, our probability of not being ready to transmit is 0.05. And my formula is going to be 1 minus p to the x minus 1 times p. So 1 minus 0.05 to the 10th minus 1 times 0.05. And here I don't have I only have a singular value, so I can go to straight to geometric PDF. Second vars, geometric PDF, 0.05 is my p value. My x value, I want to have my first success on the 10th value, is 0.0315. What's the probability the first terminal not ready to transmit comes after we've tested 20? So 1, 2, 3, 4, dot, 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 19, 20, 21, dot, 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 all the way to infinity. So I want it after 20. So this is what I'm looking for, is after 20. So, but here the calculator doesn't do that. So how many did I have to test? Well, we know it's going to have to be this. I got more than one value and I have infinity circle. More than one value in infinity circle. This is 1 minus the highest value. 1 minus the highest value not circled. Let me show you again. 1 minus the highest value not circled. So in this case, 1 minus the probability that 1 minus the probability that x is less than or equal to 20. All right. Less than or equal to 20. 1 minus the probability that x is less than or equal to 20 is what we're looking for. So multiple values, I'm going to have to use the summation sign. So my sign is going to be, my equation is going to be 1 minus the summation of, and then it's just my equation that we typically have, parenthesis 1 minus p, close parenthesis, x minus 1 times p. All right. And I'm going to put this part in brackets just to denote that the summation part's left off. Okay. So now I need to plug in. And when I plug in, I have to start with the lowest value, not circled. So 1 minus bracket 1 minus our p-value happens to be 0.05. Don't want to forget that. 1 minus 0.05 to the 1 minus 1 times 0.05 plus dot, dot, dot plus 1 minus 0.05 to the 20 minus 1 times 0.05, close the brackets. All right. This 20 right here came from this value. This 1 went right here. So here we go. 1 minus math summation x 1 20 second vars binomial geometric PDF, excuse me, 0.05. And our x value, because anytime you have the summation, doesn't matter if it's a binomial or geometric, we have to have an x. So the probability that the first terminal happens after the 20th is 0.3584. So the probability that it would have occurred in the first 20 is about 65% or 64.16. One thing I did not do on the problem above it, and I want to go ahead and back and do this, what's the probability the first terminal is the 10th terminal? That's the probability that x equals 10 because it is, and is means equal. The next one, what's the probability we have to test at least 30 terminals in order to find a terminal which is not ready to transmit? So 1, 2, dot, 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 29, 30, 31, dot, 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 all the way to infinity. Now, in this case, 30 is like, hey, at least 30. So 30 is at least 30. So this is what we're interested in, but we can't go to infinity. And since we can't, we're going to have to do 1 minus All right, we'll have to do the 1 minus strategy here. Our p-value is still 0.05. So we want 1 minus the probability that x is less than or equal to 29. So my equation is going to be 1 minus the summation of 1 minus p to the x minus 1 times p. Guess I could rewrite that, try to make it a little nicer. 1 minus bracket summation 1 minus p to the x minus 1 times p. That looks a little better. All right. So now that's what I need to plug into the equation, and we're going to have to start with 1, and we'll end at 29. So our x, the first x will be 1, the last x will be 29. So 1 minus bracket 1 minus 0.05 to the 1 minus 1 times 0.05 plus dot 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 plus 1 minus 0.05 to the 20 minus or 29 minus 1, which is just 28. And you can write 28 or you can write 29 minus 1. I'm going to go ahead and write 29 minus 1 times 0.05. And I'm going to close the bracket. All right. 1 minus stat, excuse me, 1 minus math summation x1 all the way to 29. Second vars, geometric PDF, 0.05 and x. Remember, as long as we're dealing with a summation, we always have an x on the end. 0.2259 is my answer. All right. What is the likelihood the first terminal not ready to transmit is found before the 100th terminal? So 1, 2, 3, 4, dot, 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 99, 100. It said before the 100th. So I'm really looking for this. All right. So I have multiple values circled, but I don't have infinity encircled. If I don't have infinity circled, I got to go through this column right here. So I write the probability statement and the probability that 1 is less than or equal to x is less than or equal to 99, because that's the highest value I had circled. In this case, I don't need the 1 minus. It just has a summation of 1 minus p to the x minus 1 times p. So this is going to be plugging in 1 minus the 0.05, because p equals 0.05, to the 1 minus 1, because that's where that first one comes from, times 0.05, plus dot 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 plus 1 minus 0.05 to the 99th minus 1 times 0.05. And here we go, math, summation, x, 1, 99, second vars, geometric PDF, 0.05. Remember, anytime you have a summation, you have x. And we get 0.9937. So about a 99% chance is going to happen before we get to 100, 0.9937. All right, that's the end of this video. I hope it helped. Hope to see you on the next one, where we will discuss the differences between the geometric and binomial and try to recognize which one is which. Thanks for watching. Bye.